For the next generation multiplayer collaborative environment, we're going to be talking about the user cases and the users involved with the project, or the amount of work the user will go through in order to access the collaborative environment in the multiplayer platform. So, as I said, we're going to primarily be focusing on the users in order to receive and initiate contact with other players in this collaborative environment. So there's actually two use cases. There's actually the single user. For instance, we'll be talking about PC or just a single PlayStation, Xbox console, compared to multiple users, which requires a lot more research and a lot more due diligence to accomplish or to actually achieve the task. So I'm going to be going over just the initial case for the users. So for the users, this is just an overall model of a TCP handshake, a send-act, a transaction. So you will have, in order to initialize the content of the gaming platform or the online gaming, you're going to have the client, which will connect to the server, and which the server will do is due diligence to either find, retrieve the gaming content, the online gaming content to which the player has left off, or to start a new game. Now it is up to the server's responsibility to actually load the content and actually save all of its queries and contents within the server. By that I mean player stats, other characteristics such as equipment, weapons, ammo, online progress, how far they're into the game. So all that done at the server. So this is actually based on the server itself compared to the client, where they're just able to access the content online. So this is perfect for within the SDN or a online collaborative environment. For instance, the cloud through Steam or PlayStation Network is a great example. So you'll have the client initializing its contact to the server, in which the server will do its due diligence, and you'll have one of two outcomes: either it will find the game and tell the player that it will connect to the game, or the game will no longer be available, in which it is lost, corrupted, whatnot, and then it will actually start a new session or redirect the player to another game for whatever reasons. And then from there, once the client is initialized within the game, they will run the game, and they will be able to receive updates, receive their content, receive whatever it is they left off to their last where they left off, in which the server will then run the game, and then it will send the client the information or the data in transit. So this is an example of a use case with the actual just a single player. So the little box around the diagram would be the console, in which the user would load the game, initialize the video game, and then once they're inside the gaming content, they're able to go to access the multiplayer content. And from there, they're actually able to make modifications, change their settings, whatever it is they do to initialize or actually conduct the online environment. And at the same time, you'll have multiple users conducting the same movement throughout the region, throughout the globe, accessing the servers in order to retrieve their game content. So if you have a centralized server environment or a centralized server hub, it could be quite gruesome for the payload because of the amount of players it is actually going to be receiving, depending on how popular the game is. But of course, the gaming industry, they will actually implement, setting up different servers across the region, across different parts of the globe in their own little data centers. So this would be an example of one of the classes or the users involved. And this is another diagram, more in depth. So this is basically a one-on-one collaboration between two players. So for this instance, we're going to be talking about our player Mary and then the opposing player John, in which their interaction with the server. So Mary is actually receiving a little lag. So this is where SDN will come into play, because Mary is receiving a slight lag, where John actually has the better end of the stick, where he has a better bandwidth association with the gaming server. So the initial throughput or the initial threshold would be that Mary will actually shoot sooner, but John will actually shoot a little bit ahead time. But as you can see, there's like a lag compensation. So there's actually, it's called RTT, or round trip time, so which the server's picking up that Mary's not receiving, the server's not receiving Mary's content in time, but is receiving John's, in which John is actually able to kill Mary before she actually actually gives up the shot, in which it would give the calculating death, in which John's interaction with the server is a lot more faster compared to Mary. So SDN will be pivotal in this moment because you have two different players, two different users, one server. So it's better when you implement SDN is actually able to be controlled on the application layer and on the networking platform, in which it will be able to better distribute the data being flowed between the two players. So if this was the initial, if SDN was implemented in this diagram, then you would see that since Mary would initialize the first shot, that she will actually kill John, but because of the lag compensation in between the two and RTT, then as you can see, John will have the better end of the stick. But with that, that will conclude this presentation or this video with the use cases involved.